I want to know how to graph this pair of parametric equations on a Cartesian coordinate system. For that, we have to get this from two parametric equations down to one singular Cartesian function. And so to do that, we'll need to have a function y equals to some function of x rather than these t's running around. So for that, we'll do two examples. So this first one, we could use a method of substituting one to the other. I'm going to use x's function to plug into y's using the following arithmetic. So if I isolate the t function, the t variable, by way of subtracting 1, then easily I can see that t is equal to the function of x minus 1. That gets to go in here. And now we'll have very quickly y back into a function of x. So previously y was 2t squared. Now we can make that substitution, x minus 1 squared. And that is the function now y in Cartesian form. That would look like a parabola. So we see that there's some transformations going on from the parent function of y equals x squared. There's a shift to the right of 1 from the original x squared, and then it's also stretched from that coefficient of 2. So approximately a little bit over 1, maybe a bit more narrow of a parabola like that. Okay, so that's the first conversion to graph on a Cartesian plane. For our next example, we have trig functions where we're going to utilize the famous identity. So we know that cosine of x or cosine of t squared plus sine squared and let me move that power here so it doesn't look like t is being squared. That should equal 1 on the unit circle. For that reason, we can move things around on this pair of parametric equations so that we just have sine and cosine, and then we'll apply it to that identity. So just a reminder that this is an identity we're using. Okay, so if x is equal to -2 sine of t, let's get rid of the -2 on both sides. So we've got sine by itself. Great. Now the second function was y equals 5 cosine of t. I'm going to divide out the 5 so that I have cosine by itself. And that would equal y over 5. Great. Let's bring these together, all together in that identity. So we'll have cosine squared plus, I want to make sure to distinguish the t's and the plus signs here, plus sine squared of t equals 1. And now we'll make those replacements. So cosine was -x over 2 gets squared. Sine was the y over 5. That got squared. Was 1. We'll see that we'll end up with an ellipse on the Cartesian plane. This turns into x squared over 4, y squared over 25 equals 1. And so this is the very famous form of an ellipse formula. So ellipses are sort of elongated circles where each the lengths for the different hemispheres on that ellipse are going to depend on what are in the denominators for either variable. So that means the width on the x or horizontal stretch of this ellipse is going to be its size square root of 4 or 2. And then the vertical stretch of that ellipse is going to be the square root of 25 underneath the y variable. So that'll be, give us these points, 5 and -5. Sort of round out our ellipse, and then again on the x-axis, highlight those 2 and -2 ends of our ellipse. As rounded out as I could make it, but that's how you would convert that pair of parametric equations to Cartesian form and graph. Those were 2 examples of how you can go from parametric equations to Cartesian equations and then a graph.